It's kind of like a tag team, so you may hear Dwayne from the back, and he's far more entertaining than I am, so I'm just going to do my best to warm up the crowd. So anyway, yeah, like Paul mentioned, I'm Carl Grunwald. Been with MnDOT for, it'll be 17 years in August. Worked for consultants in Wisconsin doing building design, bridge construction inspection, and had various roles in the bridge office over my career here. So as we go through this, if anyone has any questions or wants to bring up a topic, raise your hand, jump in. Yeah, just keep it loose. So slope protection is session 19 that we'll be covering here. So a little bit of introduction. So there's various types of slope protection that you'll see on bridges as you're inspecting them. The main types are riprap, and then there's aggregate and concrete slope paving. Every once in a while, depending on flow characteristics, you may see a grouted or a matrix riprap. But a lot of times it's the main three riprap and then the two types of slope paving. There's a couple other less common types. I've never seen a plan with hand-placed riprap, but it is in the spec. And then gabions and revet mattresses, which are essentially baskets that are filled with rock. And I just want to stress the primary purpose is erosion control. And don't ever cross Dwayne when it comes to erosion control. So it's a very important piece. We don't want to be discharging any soils into our waterways. And so it is an important element. So here's our outline. We'll go through these 5 bullets, a little bit of background information, and then cover the main types of slope protection. So we'll start with the background. So there's 3 main specs that are covered here. 2511 for riprap, 2512 for the gabions and revet mattresses, and then 2514, and that covers both aggregate and concrete. And then you can see in this listing there's a few other ancillary specs that are related to it that you'll need to reference when you have a project when you're building a bridge. So what can you, I guess looking at this, what do we see here? What's the issue we're encountering? Big time. Any ideas as to how this is happening?
Coming around the corner of the wall.
It is coming around the corner of the wall, yep. So we got this big ravine right here. And you know, this structure already has the superstructure on it, and so you know, this should have been probably covered long before. Now this could be a picture from a rehab project, but we want to make sure that we get this down. Dwayne, isn't it like 7 days soils can remain uncovered?
Yep, depends on where it drains to, but yes.
Yep. So, you know, long time ago, this has been left uncovered.
They blew it.
That's something we want to get after sooner than later. So again, primary purpose of slope protection is erosion control. So I know you guys all have the plan set, 27-138 if I remember. Can you pull that plan set out? And go into sheet 5 and 35 and 60. Just a little plan reading exercise, pretty simple. But essentially we're looking for bottoms of footings and the grade line. So here's the southwest wing wall elevation. And can anyone tell me, looking at the 2 bottom of footings, what are those elevations?
416? Brown?
No, bottom of footing. So we got a main abutment footing here, and we got a little step footing. What are the 2 elevations that we're seeing?
856.42 and 863.62.
Yep. So usually they'll have a leader arrow with the elevation pointed to both, and that's what the contractor is going to use to establish elevation. They'll also use that to establish where the pile cut off. Not that we're going to cover that in this section, but how about the ground line? There's 2 elevations that is, I guess, assign where that ground line meets the front and the back, or the upper part. What are those 2?
867.5 and 864.16.
Yep, so we got an elevation up here and down there. That's exactly right. So when after they've built the structure, they're going to come in and put material back in to finish the final grade. So you're going to want to make sure that the walls are that height, and then down here. And part of the other reason why we want to make sure that's there is in design, the designer is setting bottom of footing elevation down here and here based on minimum cover requirements. Okay. Now we'll turn to sheet 16 of 62. We're going to look at the north abutment. So instead of an elevation view of the wing wall, now we're looking at the abutment in plan and the front face and elevation. So again, let's, you guys could identify the bottom of footing elevations for the main abutment and the footing for the wing wall.
154, 147.
Yep. So here again, I highlighted where those are called out. Leader arrow to the bottom on both. And then on the front face, there's also a line that shows where the approximate grade line here. And you can see from the left hand to the right hand, there's a slope difference. And that could be because the roadway underneath is at a slope, or there's a skew difference from where the tie-ins are. But what are the elevations on those two ends? Yep. So there again, leaders are called out at both ends, and those should, when you look at your wing wall pages, those should match. From there to there, and then from here back up to there. Again, these are important. I've seen projects where a contractor missed this, and it's not quite this much fill, but they actually just filled to the top of footing. And that created all sorts of issues, because then when they tried to tie in at the end of the wing wall, it's low. And then you get water that comes around the edge, and you can end up undermining the underside of that E8 joint sill. So this grading is important to protect the structure. So pretty simple, but good to cover. So in selection of the type of slope protection, this isn't anything that you as an inspector will need to do, but might be helpful to understand why. And so among some of the factors that we consider, steepness of the slope. Obviously, the steeper the slope, the less stable it is. Is the slope exposed to weather or not? If it's under a bridge, or if it extends out, that we have some disturbance outside, that may dictate it. And then whether or not it's visible to the public, has access, or if it's at a river crossing. So of the types, typically you're going to see the coarse aggregate and slope paving. Over adjacent to a railway or a roadway. You would not typically see, and if you do see it, I would ask the question, if you're seeing concrete slope paving or aggregate next to a stream or a river, ask the question. That's probably a mistake. The aggregate slope paving, some people think it's maybe not as aesthetically pleasing, so you may not see it next to a walkway, high pedestrian traffic area. And then riprap has a granular geotextile fabric underneath it, which we'll get to. It's typically used at a waterway crossing, and that's because it has very good resistance to scour. Of the water running over it, it's going to protect that slope underneath. So move on to specifically the riprap and the various types. Again, covered in 2511, and then there's a listing of additional. So you got 3 material specs here, and then 2461 for any grout that you might have if the project has a grouted riprap. So for fully grouted, you're going to end up using a 3A. So this table is from 2461 right here. Not expecting you to remember all these mixed, I guess, specifics, but just realize that if you're going to have a fully grouted riprap, it will be 3A grout. Riprap is classified by type and size, or class, excuse me. So the type is random, hand-placed, or grouted. Again, I've never seen a project with hand-placed. It would probably be something that is historically significant where you really want to have that aesthetic. Random is very, very common. And then grouted is used sometimes when you have really high flows, and oftentimes it's now called a matrix riprap, and it's not quite. It's maybe 50% grouted, and we'll get in and talk to that. And then the class is the stone gradation and size. So you got type, and you got a class. Riprap's also then placed on either a granular filter or it's on a geotextile filter to separate it from the underlying soil beneath it. So just some statistics here, I guess specs. So you're going to need to have at least 1 foot for riprap. As the type and size or class gets bigger, that thickness gets bigger, but a minimum of 1 foot, and then it'll be 6 inches if you have a granular material filter underneath it. But you need to take a look at the plans and verify that, okay, if I have a type 3, it's going to be larger than that, but these are the 2 minimums that you'll be looking for with random riprap. So before you place the riprap, just like, creating a roadway, you gotta, prepare the base, right? So we're doing the same thing when it comes to riprap. We don't want to just leave it high spots and low spots. We want a nice uniform base to place the riprap on so that we know when we place it, we have a uniform thickness. So essentially there's a couple options here. We're going to excavate and shape it to the cross section shown in the plans. There's also a standard plan figure that's going to provide details, or as staked out by the engineer. So despite our best efforts, when plans are put together, there's instances where you get out in the field and you just look at it and say, this says only to go 5 feet out from the edge of deck. Doesn't make sense. I need to go farther to get this tied in. So the engineer may make some adjustments to that, and obviously then the contractor would get paid for those differences, but we want to make sure that we're providing slope protection that's going to do what we want it to do. And then just like a road base, we're not driving sheep's foot or smooth rollers out there, but we want to make sure that foundation material has some compactness. Right? We don't want to have super loose material that when we place the riprap on it, it's going to settle 2 feet, because then that's going to defeat the purpose of it. So we want to compact that before we're placing the filter material, and then obviously the riprap after it. So here's your standard figure, 309. This is what you're going to see if you have a project with riprap. Just wanted to highlight on this page, so we talked about the type and class. We've got random riprap here and then the class. Now, this standard has this little box, which calls out class 3, 4, 5, and then this T is essentially your minimum thickness right here. So the front sheet will usually call out, and it will call out what class you have. So if you have a class 4, then you know that when you come back here, your thickness is 2 foot. That's what we'll be expecting the contractor to place. So after the grade has been compacted and shaped for the slope that we're going to be placing, filter material needs to go down. So we're going to be placing it under the riprap unless required by the contract. So maybe there's an instance where we don't want to have anything underneath. But most of the time you're going to have a filter material, whether it's granular or geotextile. So the granulars, we're going to place it at a uniform thickness of 6-inch minimum across the entire area. And when we get to depositing it, usually you're going to be using a bucket. There could be other methods. But in water, we cannot be discharging material above the water surface. Can anyone tell me why we don't want to be putting it above, dropping it in the water above the surface? Yep. So as the sand material hits the water, it's just going to go. We don't know where it's going. It also creates turbidity as you place it. So we want to get the bucket underwater. Is it going to be perfect? Is that surface underneath going to look perfectly smooth like it shows in the plan? No. I mean, we all know that lines on paper look great, but things in the field don't always look like that. We understand that. And then the material, we need it to be well graded, just like everything else. We want it to meet the spec and the intent of what we're trying to accomplish there. So the granular filter material, those requirements are in 3601. So the class 1, so that's the smallest size, that's the 1 foot thickness. The granular filter is based on the class 5 in 3138. All other classes, so 2 through 5, and if there's anything special or larger, there's a separate table for it. Not going to expect you to remember this, but so here's this. This would be this table 360122 for class 2 and larger. You can see you've got material that's passing the 3, everything passes the 6, but kind of gives you an idea what that material is going to look like. The geotextile, so we talked about the granular filter that goes under the riprap. The other option is geotextile fabrics, and I'm sure most of you are familiar with geotextile fabric. You know, it comes in 15-foot widths and long lengths, and you roll it out on the slope. That's covered in 3733, and here, look a little bit at the standard figure 309. So there's a general note here that we'll take a look at. So most of the time you're going to have a type 7 geotextile, but look at your plans. Obviously there's instances where hydraulic engineer may require something different, but that's the standard type. Again, we just want to make sure that the slope, when we're preparing it, we don't want a lot of rocks, stones, sticks, or anything if we're going to lay down geotextile, because if it's irregular or something's poking up, it's going to puncture it. We don't want to pay for a car with a dent in it, right? We want to make sure things are put down properly, so do our best to make sure that it's prepared and it's, you know, free of those types of sharp objects. And an important one here is we don't want to be operating equipment on the geotextile fabric. You can imagine if you're driving a track excavator over it or some other material or equipment, it's going to shift it, it could rip it, tear it. So we're not allowed to do that. And then the fabric, you know, if it comes in a 15-foot wide roll, that's 200 feet long, and you've got your, say it's water flow is going from this side of the room to that side of the room, and your slope's coming down from top of the ceiling down to front row, we want that longest dimension rolled out that way. If you're rolling down this way and water's coming across it, do you think that's going to hold up real well as we get a flood event going? No. So we want it laid with the longest dimension going with the direction of water flow. And then here's just some requirements. You know, if the fabric isn't seen, there's requirements in the spec on how much it must be overlapped, whether it's above water or underwater. And then you want to make sure those joints are lapped in a shingle fashion, just so water runs over it as it's coming down. Again, we don't want to be operating construction equipment directly on the geotextile. And then once riprap's placed on it, we're not operating on top of the riprap either. Because obviously that large equipment's going to push the rocks down, and that could puncture through the fabric. And then we'll look here at this figure 37, or the 309 standard. Talk a little bit about when we get a slope between 1 to 2 and 1 to 3, it needs to be retrenched. So you can see here we got this detail. So this would be under a passage bench, which we'll get into and talk to a little bit, but it gives you a detail of how those 2 layers of fabric need to be overlapped. Same thing down here. This would be just your standard every 15 feet, and it says repeat as needed. So if you have a really long slope, you may have 3 or 4 of these that you have to make sure the contractor gets dug in, and then have the fabric overlapped as well. Again, riprap class will be specified in the plans, and we need gradation requirements, which are in this table 3601. I have had a couple projects where staff have asked a little bit, just saying, hey, this is the gradation that the pit has. I'm not real great at reading these, but I do know people in the geotechnical office that are really helpful at that. So if you have any questions with that, you can give your regional a call. We'll likely reach out to the foundations office, or you can just contact them in general, and they can help with this, making sure that you got the right type of riprap. Here's the class 3, 4, and 5, just the gradations for each of them. You can see here on the end, the max size is 18 inch. If you remember back to the table on the standard plan, the maximum thickness, or the minimum thickness is 18. So if you have a section wider than that, that's the upper limit, and that's how it's set. The material, we want to make sure that each stone has at least 1 fractured face. Can anyone tell me why we want 1 fractured face? So if you have, large river stone or cobbles and they're all round and they're laying next to each other, they're going to act like ball bearings, right? That's why the spec has at least one fractured face requirement in it. We also want it to be free of soil and debris. Why might we want it to be free of soil and debris when we place it? Yep. A lot of times we're placing riprap where?
Against water sources.
Yep. So we don't want a lot of that material in there as we're placing it because that could become a release. Less than 10% by weight. Want to have, we don't want it to have defects that could cause excessive deterioration. And then we want to make sure the stones have with thickness less than 30% of the length. So you don't want real thin slabs out there either. That's not going to provide what we're looking for. And then we'll look at a couple pictures of material that likely had insoluble residue from the number 200 that's more than 10%. We'll take a look at what that looks like. And then we want it to be 100% virgin material. So here's some riprap being delivered. Opinion here, does it meet the one fractured face requirement? Do you think this is going to have material that's, I'm just kind of looking at the picture, is it going to dissolve? Is it going to be soluble? No, I'd say this is kind of a pretty good igneous rock, right? It's not sedimentary. Cleanliness, how does it look? Yep, looks pretty good coming out of the truck. Maybe in the stockpile they got a little there, but not too bad. Here's another picture of that material as it's sitting there, and it would be considered acceptable. What do you think happened on this piece? Freeze-thaw, yep, there's maybe some of that soluble material in there that after a winter of water getting into it, it leached away. So this piece started off being rather large, right? Now we got 30 small pieces. When you got a flow coming through at 10 feet per second, do you think that's going to hold as well when it's broken up into a bunch of little slabs? No. So this one's an important one, and this was a District 7 project. Want to be on the watch out for that. So it's going to be more of your sedimentary style rock that's going to have this kind of issue.
So if that was a year later, how would you know when they actually brought it out that?
Well, that's where, yeah, some of that testing, that's where I really lean on the geotech folks to help with that. It's probably more knowing what pit it's coming from. Some may be more prone to it than others. But yeah, this one was a year or two after construction. And I'm sure that it didn't look like that when it was placed. Maybe it had indications of it, but just be on the lookout for that. So this would not be acceptable. And here's one that Dwayne ran across. Here's just another example of material that's just degraded over time. Dwayne, do you remember how long this was out there?
Didn't even make one winter. Didn't even make a year.
So yeah, we're looking for a large rock like this, and we're ending up with something much, much smaller in a short period of time. So
And the project wasn't done yet, so it can be corrected even if the bridge was done.
yeah, so there's an opportunity there. If they place riprap before you set beams or something, you can kind of keep an eye on it as the project goes. And hey, you seeing this type of issue cropping up? Say something before the project gets closed out. So not acceptable. Just a couple. This is the hand place. Again, I'd be surprised if you see a project with it. So it's just a little bit of information on it. You can refer to it in your slides. I won't spend as much time on it. But grouted, it's going to be typically a 3A, but always look at the contract. So when you're placing the riprap, you've got the fiber material down. Everything's been graded before that's been placed. So now the contractor's bringing the material out. So we've got a limit of 1 foot drop on that. Why would you have a typical or a max drop of rock? You don't want to be damaging the filter material, right? If there's a granular cushion core called for the plan, if it's 6 inches thick, then you can increase that to 3 feet. Obviously, that 6 inches of granular cushion helps minimize that risk. And then, let gravity be our friend. Let's start at the bottom and work our way up. Contractor's gonna do that anyway, just because it's gonna give them the best access. But that's just how it gets placed. There's an option, it's at the engineer's discretion, but they may require the following. So there's an option to demonstrate, they may say to the contractor, hey, place some fabric down and put riprap on it, and let's see what it looks like, right? It's kind of like a mock-up. Are your means and methods such that you're not going to damage the filter fabric? And the other one would be, they place all the material, now we're going to uncover 4 square feet, and we're going to take a look at how does the fabric look underneath. The type of rock, you want it to be placed in the uniform distribution. So you don't want all your largest rocks sitting next to each other, and then 5 feet away you've got all the smallest rocks sitting right next to each other. They're not going to perform the way we want. The large rocks leave voids in between, and we want those to be filled with some of the smaller ones. So the goal is to provide a well-keyed mass of rock. And again, it's not going to be perfect, right? If you've been out on a bridge and you walked on riprap, you can see there's voids in it, but trying to get the least practical amount of voided space as possible. And then some leveling may need to be done just to make sure we're not, we don't want it up and down 2-3 feet. And here's another info slide on the hand place riprap. I'm not going to go through that. If you have a project with it, give me a call, because I'd love to hear about it. But if you do, here's some information on it that's covered in the spec. Okay, so based on what we've talked about, does anyone have any concerns? If you walked up to this as an inspector, what would you be thinking?
River's not protected.
What's that?
River's not protected.
Now, I don't see anything along the river there. I would agree.
Where's the filter material?
Yep.
It's
Now,
dirty.
this one could be that they already had some placed, right, and it's underneath there, so it could be. But yep, you want to lower your filter. Is anything
Dirty.
very dirty? So what do you think a contractor would do to, would they want to be cleaning that off down here?
No.
They sure try.
They would try. What would you say if they tried to? What are you gonna do to contain this, right? Okay. All good points. Do you have any concerns about the rock itself? Does it look okay? Maybe, yep. Hard to tell with all the dirt on it. So these would be good things to talk about even before they start placing the riprap. Right? Talk through that, have a pre-activity meeting, talk with the contractor about what they're planning to do. Here's another way of placing it. This would be, I think this is from a maintenance operation, but if you don't have access down below, it's obviously getting equipment down there, you're gonna have access roads, and that could create, need for permits, whatever. So here they used kind of a clam bucket to lower it down and place it. This is obviously just adding riprap to an existing set of protection for that pier. Just a schematic, probably just common sense, plain obvious, but run through it anyway. So remember, we want to start at the bottom and work our way up. So this detail C is the toe-in at the bottom of the riprap slope in the river. Does anyone think we're going to get exactly that? No. What would you say? Do we notice that it's maybe a little thicker than the main slope itself? Yep. Trying to get maybe some wrapping of the rock, of the fabric around the rock. So the intent here is just to make sure that we've got a good base at the bottom. We'll do our best to get what's shown there, but lines are easy to draw on paper and hard to accomplish, especially when you're underwater here. So the contractor is likely going to need some turbidity protection there. A lot of things will go into this piece. Once that in, now they're going to work their way uphill. They're going to lay that first section of fabric up, and then we come to that first point. Every 15 feet, we got to trench it in. So we're not going to be placing a riprap in this until, are we going to be placing a rock here before we've got some down there? No, because you're going to end up with some issues probably with your fabric too, right? It's going to be difficult for the contractor to get it placed that way. we're getting that detail D. Continuing uphill, just so happens this one on the standard is showing the passage bench. We got another tie in here. And we're continuing up to the abutment and completing the riprap placement. So speaking of passage benches, Dwayne, do you know how long we've had these? Do you remember?
I bet they're 10 years old now.
Okay. Anybody know why we'd have a passage bench?
Animal critters.
Critters, yep. You can see here, we're giving them a exactly 3 foot wide passage bench. Now, I'm kidding there. So a couple options here, and a lot of this is, you know, we can, standard details try to give the intent of what we're trying to get, but a lot of what's going to happen out in the field is going to be, hey, does this make sense? Want to make sure that how would a deer, how would an animal come through this waterway area? Because they're using waterways. It's, Dwayne, I don't know if you said it, it's kind of like their highway essentially.
Yeah, that's what it is.
And so when you come to a bridge and I go out to them and I see these passage benches, you see hoof prints, you see all sorts of stuff in them, so they use them quite often. Essentially here, just kind of go through the details there. So it's 3 foot minimum, and we want it to be generally level. If it's a little wider, no problem, right? Then we've got these 3 circle notes, which this may be hard to see, but essentially just pointing out that there is going to be a reference to another plan sheet for dimensions and elevations of riprap and the passage bench. The standard is not going to give you the elevation of the passage bench, and that's set based on high water and contours, right? So we want to make sure that in normal flow, this stays open. We don't want it down below, it's underwater, it's not going to be usable anyway. So you're going to have to refer to another sheet to find that. This note talks about starting from the bottom and working your way up, and not placing riprap in the trench before everything up to that point is placed. Just kind of common sense. And then the passage bench gets surfaced by a coarse filter aggregate. So it's in 3149, I won't expect you to remember that, but this is how it's graded. So you can see everything's passing the 1 inch, so it's 3/4 inch, so it's kind of just a rough gravel. Just enough to, if you've ever tried walking on riprap, I got big feet, it's still tough for me. I can't imagine a deer trying to do, their little hooves trying to walk through it, not good. So the goal here is to fill that area so there's a decent walking surface. Grounded riprap. Well, we're wanting to make sure that, I guess, concrete needs 2 things. It needs water and temperature. So this first bullet point, before we're placing grout, we want to make sure that the rock is wetted. If it's an igneous rock, it's probably not as big of a deal. If it's sedimentary rock, you definitely want it wetted. We don't want that underlying material sucking moisture out of the concrete. So pre-wet it and then re-wet it when needed. And then for fully grouted, we're wanting to make sure that that concrete fills essentially everything throughout the entire thickness. I don't think we have too many fully grouted ripraps anymore, but if you do see that, that's what we're looking for. And then that surface gets swept with a stiff broom. We don't want it to be finished smooth because, frankly, I'll be out there looking at the bridge and I don't want to land on my rear end. You may see matrix riprap. If you're going to see a grouted riprap, that may be one. This would be by special provision at this point. Hydraulics folks and probably environmental folks would prefer the matrix over the fully grouted. It's paired up often with the type 3, so the 1.5 foot thick. And instead of using the straight up 3A grout, it's got a modified, and that'll be in that special provision. And it's got, I guess the way it's been described to me is it looks like a Rice Krispie bar and it's done. So it's not completely full, and the way it's described is you're looking for 50% of the void to remain after the grout. It's a little more flexible, so if there's some shifting in the slope, it's not like it's just going to crack up. So that's one of the benefits of it. And then often it's used at water crossings with really high velocities. And after last summer, with all the rain in District 7 in the southern, at least for me anyway, you see how important this slope protection is for the structure. So here's an example spec from that special provision, just for your information here in this packet. So Paul, can't remember, if you can't get to that shared drive, I probably don't have those videos for the test then either, or would those have been pulled over?
I don't think I pulled any of those videos.
Well, I got, if anyone's interested about seeing this, so there's two tests. There's the standard American slump test for this product, or this mix. You're gonna range of 6.5 to 7.5. Then there's a European flow table test. And it's got a specialized cone and a table. So if anyone is interested, I can send it, or at least try to get it to you. It might be a little larger file. You can see what it looks like. Maybe let Paul know if anyone in the class would like to get it, I can get it out to you.
Is that what's right there?
It's like a spread, but then this table essentially is on the end and you pick it and drop it. Which I think we talked about a little bit here. So this European flow table test, yeah. So you take and the cone gets flipped over, and then you fill the cone in 2 layers, and then it's routed 25 times each. And you pull the cone up, allow it to spread, and then you take your first measurement, and then you pick up the table 15 times, drop it, take a second spread measurement. So we have a video of it. I apologize, I have shown it in previous classes, but I didn't bring it on a flash drive, so. Anyway, if you're interested, let me or Paul know. Let me know before I leave, or let Paul know before the class is done, we'll get it to you. And if you do have a project with this, the MnDOT Bridge Hydraulics Unit has this equipment. I know inspectors have asked for it before when we've had this in projects to borrow it, because it's unique. So you can reach out to regional bridge engineer or contact MnDOT Hydraulics unit in the bridge office. There's application rates, application codes are trimming. Again, you want 50% of the voids left, so that Rice Krispie bar. And again, I won't expect you to remember these application rates, but they're in that spec. So here's a picture of it being placed. So you can see there's voids still in here. A fully grouted, you're not really going to see much of that riprap at the end. But we're just filling the voids in between. Place with the hose. And then this is the finished product. So you get to see a couple of different things. You got the passage bench here with that granular material. And then if you use your imagination, you might see a Rice Krispie bar there. Or maybe it's just after lunch and I didn't eat for a while. So.
That's a really big Rice Krispie bar.
Yep, I'd go for that. Okay, so project example, this is not from the class, but this was one up in District 1. I worked on when I was in the preliminary bridge design unit, I worked on this bridge. So as you can see here, this was a double box culvert on Trunk Highway 61 on the North Shore, and it was being removed and replaced with a single span bridge. So you can imagine fill going all the way down to here, up and then back down. So you change from a box culvert to a bridge, it's going to change the characteristics of that channel, right? So this is pretty involved. DNR also wanted a trail, so that's highlighted in purple. And just to illustrate, we looked at that standard plan sheet for riprap. It referred to a different sheet for this elevation. So this isn't a passage bench, but this is where you'll find that information on that first GP&E sheet. In green here, that's the passage bench on the other side for the critters. And a quick blow up of that, and there again, there's that 3 foot minimum, and the elevation of 610. So again, that elevation is selected so that it's, normal flow conditions, animals can use it. For plan reading purposes, there's also typically elevations at these corners. Especially this one being that it was a little bit more complicated of a placement. So you got those circle notes that refer to elevations and stations. It helps define the slope and how far it should go down. And here, circle note 9 indicated what type of riprap. So this one's matrix, right? And they have a filter material. And it also, another important note here, it's included, there's some information in the grading plan too. So it's not like you can just look at this sheet and the standard plan and get everything you need. So here's the sheet from the grading plan. A little bit more information, right? Seeing contours. What do you think all this stuff is here in the middle of the creek?
So the trouts.
Yeah, for fish. So Lake Superior is over here. They're probably swimming upstream during spawning season, and this is to help give them some relief in areas. An important piece, and it's not just up north. There's some projects in the south that are obviously, have high quality trout. A lot of times this will get added into the project. So not only is the riprap important for protecting the bridge, it's also has an aspect of wildlife protection as well. So this one, and again, is from the grading plan. There's the passage bench. You got the contours uphill, downhill of that. Here's the trail. The future trail by DNR, but obviously we need to make sure that the grading's done properly so that when they want to build it, it's ready. And typically the bridge plan goes about, for riprap, it's like 10 feet outside the edge of the bridge. So that's why this, you're going to need to refer to other portions, because check out that culvert. Now we can't just leave it once you get outside the bridge and say, yeah, good enough, right? We got to make sure that this ties in on all these 4 quadrants. So that's why this plan sheet was developed. And here's the finished product. So in purple you can see that bench for the future trail, and then on the right hand side with the green arrow, that's the passage bench. Then you can see down here, if we go back to this, this has these nice, really good lines with randomly placed stuff. It doesn't always look exactly like that. And as an inspector, you may want to, contact the environmental, whether it's DNR or somebody, and say, hey, can you come out? Is this what you were envisioning? Is this what we were looking for? Pre-activity meeting and invite them to it to talk about placing riprap in the channel. Just make sure everyone's on board so we're not doing work twice. No surprises. Another aerial view of it, taken during the fall, obviously, nice, just south of the tunnel here. Looks like it turned out really well from my perspective. Not in the north, but I think it looks really good. So moving on from riprap on to gabions and rubber mattresses, not going to spend a ton of time. They're covered in 2512. You're probably not going to see them very often. Essentially, they're large baskets that are constructed of woven metal-coated wire. Their units are subdivided into compartments that get, the compartments get filled with rock. I've typically seen these use more retaining walls than slope protection, but maybe you'd end up seeing it. So you kind of see here, there's the baskets filled with rock. The rubber mattress is the same thing, it's just flatter. So it's more wide and rectangular basket. The rock that goes in it varies in size based on the type of, whether it's a gabion, it's a little bit larger rock. If it's a rubber mattress, it's a little bit smaller. All right, any questions to this point? Have I bored you sufficiently? Are you just waiting for Dwayne to come up here? It's okay, you don't hurt my feelings. I agree, Dwayne's more entertaining to me. Anyway. Aggregate slope paving we'll cover next. So, like I mentioned at the beginning, aggregate and concrete are covered in the 2514. So here's a table that includes the material characteristics of the aggregate to be placed. So there's 3 different types with a little bit different gradations, obviously. Contractor can use any of the 3. I just want to let you know. They should let you know before they fix it, obviously. Some just general information, the standard plans, the .302. It consists of coarse aggregate. Once a coarse aggregate is placed, it needs to be coated by bituminous to help bind it together. So here's the standard plan sheet for it. So you can see there's 4 different options, right, based on bridge configuration. So when you get to an actual project, it'll have the one left and everything else should be crossed out. But you're not gonna, it's not gonna look exactly like this, right? There's gonna be some field adjustment to make things work. Similar to riprap, you gotta prep the base, take out high spots, fill and compact low spots. And then there is a reference to 2106 for quality compaction requirements of that surface. There's an excerpt from the 302 standard plan. So at the bottom, you know, the aggregate needs something to keep it in place, right? We want to define those limits. So what's called for is double 2x6 and this treated timber, and those go in at the sides and the toe slope. And the circle note 1 in the standard plan gives you direction as to how it's to be treated. Another excerpt of it, so mechanical or hand methods, you can use to deposit it, and you're just looking for uniform depth and density. Probably not going to have this. You might have it on an older bridge. If you're doing a rehab, you may encounter this where you've got deck drains when they just drop straight down. New bridge, you're not going to have that. That's just not a go anymore. But old existing bridges, if you're maybe having to replace the slope paving, you may enter that. But if you have a deck drain and you want to put geotextile fabric, type 3, under the aggregate in those areas, and that's just to reduce erosion. So here's the minimum thickness for aggregate slope paving is 6 inches. Which corresponds with the 6 inch 2x6 on the side. Once the aggregate's placed, now it needs to be stabilized by bituminous. So there's liquid asphalt with a couple grades and then an emulsified version. And again, that's to stabilize the aggregate. So here's some requirements for liquid, gotta be greater than 40, and there's an application rate. And that's slightly different for emulsified. Again, I wouldn't expect you to remember that. Just be aware that it's in the spec. And then we want the bituminous when it's placed to get down half of that thickness. So we want to penetrate 3 inches. Some precautions. Obviously, when you're placing bituminous and it's in a liquid form, it could splatter. So you want to protect adjacent structures. And then you also want to protect from accidental release in the surrounding environment. So this is a picture Dwayne gave me. Won't say where it happened, but anybody see any issues with this? Got some rutting in the material down there. Yep, anything else? Down here?
You got water under one side, so they do.
Yeah. You got a whole bunch of that liquid asphalt that got out.
Mm-hmm.
Is that what we were hoping to have happen? No. So as an inspector, what might you do to help avoid this? What could you do? Yeah. Tell them after the fact, hey, I didn't want that. Right?
Work reactivity meeting?
Bingo. Talk about materials. What are they going to use? How are they going to place it? What methods are they going to use? Do they have any environmental controls? So we don't have this happen. How about contingency plans? If something does happen, what are we doing? Pre-activity meetings are a really, really good tool to use as an inspector. Anytime you can have a conversation with a contractor and talk through things ahead of time takes away. Everyone knows where everyone's at. You can state what you're looking for. You can understand how they're going to do things and ask questions and maybe head things off at the pass so that we're not trying to clean this up. So, Dwayne, what ended up having to, what was the remedy for this? Do you remember?
Well, we had to remove it. They were going to try to cover it. It was so bad they couldn't even get all the material onto the slope. That's why you see the plywood and rock. It was, but I'm guessing it was simply too warm. And it just flowed off rather than cured sort of as they went. But we had to clean it all up. And of course, there's a storm drain inlet just a few feet off of this picture.
Down this way?
Yeah, down. It's drain is from towards us.
Yeah. So it added cost to the contractor,
Yep.
you know, people are getting, probably excited about it, it just Looked like it was something that happened in the afternoon, maybe on a Friday. Probably wasn't fun to enter the weekend with something like that, so,
So waste of material.
yep.
And if you're trying to get half of that thickness with the asphalt material, I'm guessing they got much better depth penetration.
Yeah,
But again, it's using more material than you're asking for.
right. Plus the risk of it getting into that storm drain too.
Yeah, so it actually did discharge, so it was a state duty officer call.
So it turns into a pretty big headache, which, as mentioned, you can have a pre-activity meeting, doesn't mean it's not gonna happen, but
Yeah,
maybe talking through it gives people ideas of, yeah, maybe let's try this instead, right? So here's just a photo of the shaping and grading process in, I guess being worked on. We want to make sure it's compacted as well. This is being, looks like graded by hand at that point. We want to make sure we're starting with clean aggregate, try to keep it clean. And then here's the completed picture. It may be hard to see, but there's that 2x6 that sets the delineation. Would this be a good use of aggregate slope paving, or a good location for it? Nope. Water comes through here, 5-6 foot per second during a flood. This is not going to hold. So again, we're 99.9% of the time not going to see this, but if you do see it, ask the question. Better to deal with it. This is an old bridge here, but better to deal with it beforehand. Never a dumb question, just ask it. Somebody can just point it out to you and you say, all right, I did my job. Okay, concrete slope paving. So again, 2514. The concrete mix typically is a 3F52. And the rebar minimum grade is grade 40. Here's from 2461, so in the concrete mix spec. You got flat work. There it is. 3F52 for concrete slope paving. That's the standard. Here's the 301, the standard plan, and that will be, if you look in your example bridge, it does have concrete slope paving, so we'll take a look at that a little bit, I think. So this is just the bare bones standard. You can see it's similar to the aggregate where you've got a bunch of different bridge configurations, which that's what a standard is. So here in contrast is for bridge 27138, so you can see they've got what doesn't apply is crossed out or hatched out, and this is the detail you should be using right there. And then here's a blow up of the panel. So actually no, this defines the distance from edge of deck. So in this case, we're going 2 feet out from the edge of deck. We want to be 4 inches thick. And here's what's shown in the standard detail, and that's how you can see that the panel itself is 4 inches thick. It's reinforced concrete, so we want to make sure that reinforcement's in the correct position prior to concrete placement. Obviously, you've got formwork on the side. Try to make sure that's close to plan as we can. Similar to placing concrete on riprap, want to make sure that subgrade is moist so it's not pulling away moisture from the mix itself. And then, as people walk up and down, you might get some displacement of the subgrade, so it's not going to be perfect again. Just make sure that it's not just grossly, you're not getting a 1 inch thick area and then an 8 inch thick area here and there. So yeah, I just highlighted here that we want the plane grades got to be within a half inch plus or minus. So just like the aggregate slope paving, where you have a 2x6 that define the outer edges and the lower toe. Similar thing happens with concrete, shows those details. And we want to place those prior to placing concrete, obviously. Set those boundaries. So this is sheet 48 if you're ever interested in looking of your example project. So there's the toe wall in orange and the sidewall in yellow. So section 8A, there's the toe wall. You can see how it's 2 feet, 3 foot deep. And the concrete slope paving ties right into the top. And there's your sidewall. So it's quite a bit thicker than and deeper than the slope paving itself. And here's a section through that, so 1'10". You can see there's rebar that's tying it in to the slab as well, just to keep everything tied together. Just like any concrete pavement, sidewalk, whatever, you want it to be relatively free of voids. Want a uniform appearance. Placement, it's either in alternating strips running in the direction of the slope, or if they have equipment that can place the whole thing at once, they can. So here's a picture of, it's an older picture of slope paving being placed. So here you can see the formwork on the side. And you've got other formwork for your alternating strips in the background. There's the reinforcement. In this case, it's old enough where it didn't require it to be epoxy coated, but it should be epoxy coated now. That's what the new standard calls for. And then here, just highlight the alternating strips. The contractor's got it set up to place those. Once those are done, then they'll form in between. Here's placement using a belt truck. However they get the concrete up there, sometimes it'll be pumped, sometimes built. Finishing, so we want to consolidate it, strike it off. I mean, it's just typical flat work, right? So once it's capable of maintaining shape, strike it off again, float it, and then broom it. Remember that surface broom again, don't want people walking up and down it, sliding down, slipping, hitting their head. So give it a little texture. There's a photo of it being placed. In this case, they're able to go top bottom. I think the mix was stiff enough. You can see it's not like it was running all the way down. And they were using gravity as their aid to pull it downhill and finish it. After final floating, if there's any edges that don't have the V-strips, you're going to have to use tools to get that finished, and then cut panel lines with grooving tools. Essentially, you just want a good uniform appearance at the end. So you probably heard about it with concrete. Again, concrete needs two things, moisture and temperature, so it's got to be cured per 2401 3G. And in this case, what cured is the stage of 30% specified strength. So this is that 2401 table, which you're probably familiar with through this class. So this would be considered a non-superstructure. This has, right here, it calls out 45, but we'll talk about that in a minute. And here are the acceptable curing methods. So you can see, I guess, we've got AMS curing compound, you can do a curing blanket, and you can do wet cure. So those are the three types of curing that are acceptable. And this is per 2514, so this is what sets that 30% strength for cure. Once you get 30%, cure can come off. So based on that table we looked at previously, is curing compound okay? What were the two other kinds? Blanket and the best kind of all, wet cure. That's just my opinion. So if you got an early spring or late fall placement, you got to watch out for cold weather. And the cold weather protection requirements do apply. So refer to those if you're before April 15th or after, sometime in October, depending on where you are in the state. Okay, so can everyone turn to sheet 1 in the plans? Okay, what is the toe elevation in that blow up for the slope paving?
6.03.
Yep. So just for those that maybe didn't see it, it's right here. So we're going to marry that up with the abutment sheet that showed the top of the slope, and then we're going to tie that into the bottom of the slope as well. Okay, what's the slope of the slope paving based on this bubble? 2 to 1, yep. So again, that standard plan isn't going to give you all that information. This is developed for this specific bridge, and that's where you're going to find that information. So here is sheet 48 of 62 if you're interested. So we've gone to the colored rebar, which is blue. Is it not on yours? No. Maybe it didn't get printed that way, but
Yeah.
so yeah, these, a lot of times you're gonna see this. But anyway, the main point is, we're looking for number 3 bar, and the E is for epoxy coating. So like I said, in that picture I showed previously, that was an uncoated bar. It's an older picture. But you can find that information. So this is a picture of 27138. And this is the detail that it was built to, so you can see the slope paving came up. Here's the face of the abutment. And there's always a gap between the slope paving and the face of the abutment. It gets filled with polystyrene, and at that time, we put a backer rod and then filled it with caulk. So you can see right here, this is that caulk joint right there. New detail will not have that. So now, if this bridge were to get built, it would have this belting. Now, belting's there to help keep water from getting into this cavity, which then oftentimes can start eroding underneath. We've seen issues with that. So here is it on your example bridge plan, sheet 48. This is where that detail is. So you can see there, if we go back to this picture, you can see there's some rustication here. So this would have to be changed, where you'd have this bottom section would be smooth for 8 inches, so you've got a nice area to connect the belting to. And then above that is the rustication texture. So here's a project where this is a recent one. So we called for 2-to-1 slope paving. You got a semi-integral abutment here. Here's the plan. Now, can anyone, based on what we just looked at for that belting detail, you see any issues with how this is drawn? Might it conflict with that standard detail? There's the ground line.
Yeah.
What are we gonna, we got ground line here, we need that belting, what's gonna probably happen right in here? This is form liner, gonna be rough. So here's a picture of it, you can see they took that form liner all the way down to top of footing. Slope paving gets pulled up to here, and we've got this piece there that's not gonna work too well for attaching that belting. So we'll fix. Ground off the rustication,
Wow.
get it smooth, as we looked in the standard plan, like this, right? We need that 8-inch area of smooth right there. And that got ground down, and then the belting got adhered to it. So again, when you're out there inspecting, if you've got a ton on your plate, right? We understand that. If you can look at some of these details, if you see something that just doesn't match between different sheets in the plan, ask a question. Way easier to do this and have the contractor adjust the forming than, I mean, this isn't a huge deal, they can grind that out, but whatever we can do to smooth things out, the better. We play an integral role in that in the field. Sheet 1 of the plan, just looking at pay quantities, so here's the statement of estimated quantities. Slope paving's right there, in this case is the P quantity, and just this is the, I believe, the bridge. You can see you've got alternating groove finish. Here's the toe wall down here, and you can see the slope paving going up. And just a few other examples. So you might, this isn't under an abutment, but in this case it was detailed under a bridge. Here you can see this was colored concrete. They were going to pour the next strip over. There's some pictures of it under construction.
What's this little 1'6" that's right above the bottom toe wall?
Let's see what sheet you're looking at.
Section A. So when you have the section AA where you got the toe wall down there, what's that 1'6" right above it?
This one right here.
Yep. No, above the toe wall.
Oh, there's a slope
Yeah,
in the
what's that?
sidewall. So it goes from hitting the surface of the concrete slope paving to then you can see here the slope paving is actually down from the sidewall.
Okay.
So there's just a slope that goes up, and that's the distance.
Okay.
Yeah, right here you can see typically sticks up, I think, 4 inches if I'm reading it right. So it's just from 0 to 4 is over 1.6. Alright. Good question. Any other questions before we review quizzes? Alright, we won't delay Dwayne any longer. Alright, the purpose of slope protection is what? Yep. How thick is aggregate on an asphalt coated slope protection? Concrete is thick? 4 inches. 4. Riprap could be used as what when installed early? What's the rebar grade minimum? 40. 40, yeah. One of the only times you'll see 40 grade acceptable, and my guess is contractors are bringing out 60, but 40 is the minimum. How about epoxy coating?
Yes.
Yep, even though all my pictures are old and I showed that. Membrane curing compound acceptable. Now, what were the other two kinds? Wet cure and blanket. If freezing weather is predicted, what are the curing needs?
Yeah, that.
Fine, cold weather. Now, I will say though, this is only during, I guess the provisions outlined here are during certain times of year. But you still need to protect concrete from curing at any time of the year, it's just that it's not as robust as what's in here. What type of material is needed if grouting is specified? This is, I'm going to say fully grouted. Have you ever heard it? 3A, yeah. That's at 2461. What type of finish are we doing on concrete slope paving? All the broom in it. Yeah. That keeps me from falling and cracking my head. What's that?
No window paint?
No window. I'm not bringing out the power trowel. How far does slope paving typically extend outside the other deck? I think I heard it. 2 feet. Again, look at that first GP&E sheet. It'll give you those extents. But yeah, that's typical. 2 feet. What's the spec number for concrete and incidentally also for aggregate?
Concrete? Slope paving? Slope paving spec or for concrete?
Slope paving. Also aggregate. 25 work meeting, yeah. How about riprap? 2511, yeah. True or false? Round stone makes the best riprap. False. That would be directly against the spec. We need 1 fraction space, so very good. Type 3 is how much or smaller? 8, yep, 18. All right. Thank you for staying awake. At least for most of it. Does anyone have any questions? Yeah. I won't stick around too long, but I don't know if you guys know our bridge construction website. My son has a basketball game, so I gotta go. Otherwise, I usually stick around in case there's questions. But you guys all know our bridge office construction unit website, so my contact information is there. Whether or not you have a project in the South region, if you feel comfortable asking me, feel free, or any one of my colleagues. Or we work as a team, so if I don't know, I've got other resources I can go to as well. So if there are no other questions, I appreciate you guys listening and participating.
Thanks, Carl. So let's take 10 minutes, so that makes her 2:22. We'll come back.
Yeah.
That's right, we gotta shut that down.